Observability is definitely one of the hottest topics these days, especially in the technology world. Maybe if you can start by helping us to understand what is actually observability, because this term is commonly used these days.
Let's contextualize in terms of both SRE and observability. Not all of your listeners will necessarily have heard of SRE either. So, when we start with thinking about what SREs do, the goal of a site reliability engineer is to try to make systems easier to operate for the people that are working on them, whether it's SREs themselves who are on call or whether it's the software engineering team that is kind of building and operating and running the system. One of those key considerations in terms of ensuring that the system is highly available is thinking about what are your service level objectives? What are your reliability goals for the system? And then on the flip side, how do we think about trying to achieve those goals? What happens if there is an incident? Does it take 5 minutes to fix or does it take 3 hours to fix? To me, that's where observability comes in, because observability is a technique for ensuring that you can understand novel problems in your system. That's why it was a natural transition for me to go from working on SRE to working on observability. So when we think about defining observability, it's basically this question: can you understand what's happening in your system and why, without having to push new code, and to do so very quickly by slicing and dicing existing data that you already have in terms of telemetry signals that are coming out of your system?
So you mentioned a couple of key points when you describe observability here. The first is without pushing new code. If I imagine last time I used to be a software developer, whenever I want to troubleshoot and debug something, sometimes I introduce new code.
Yes, that printf debug statement. All of us are guilty of it.
So tell us more about this without pushing new code. How can we actually do this?
Yeah, so the key way that we think about observability and kind of that first step of instrumentation is, as you're developing your application, you should add instrumentation to help you understand what's happening inside of your code so that you don't wind up being caught on the back foot later. That doesn't mean you have to predict every single failure that's going to happen in advance. You kind of have to lead yourself to the breadcrumbs that you're going to need to debug in the future. So this starts with, in my view at least, kind of having some form of tracing to know when did each request start and stop in each service? Where did that request come from? Which other service called you in turn? And maybe some other properties like which user is it? The more you enrich your trace gives with information that may or may not seem relevant at the time, but if you can freely add that detail of what feature flags were on at the time, which user ID is it? Which browser are they using? Which language are they using? Then it means down the road, you don't have to have pre-aggregated by any of those dimensions. You can kind of see which, if any of those dimensions are relevant.
So instrumentation, tracing, all these are being mentioned these days, and people also normally categorize it with these three pillars of observability called logs, metrics, tracing. So tell us more, are these three the most important things that we need to implement for observability?
I think that having high quality signals does matter. You're not going to get great observability unless the data is there. However, you can't just throw a bunch of data into a data lake and say that you're done. So I think that's kind of why I push back against the three pillars narrative, because one or two really high quality signal is enough. You don't necessarily need kind of voluminous debug logs if you have tracing that is representative of what you would otherwise put through into logging. Metrics can be useful in high volume situations, but the problem with metrics is that they're pre-aggregated. You can't re-slice the data once it's been pre-aggregated at the source, right? So I think that each signal has some benefits and drawbacks that you need to evaluate, and you don't need to collect all three of them. In fact, there are new and emerging signals like continuous profiling. So there are not really even three pillars or lenses or whatever you want to call them. There are many different telemetry types that we can think about utilizing as we kind of compile this capability that's really not a technical capability, but instead a socio-technical capability. What can your engineers accomplish with the system? Not what are you measuring out the system, but can you actually analyze it? Can you actually get that result of I can understand and figure out what's happening?
So one thing that is also interesting for me when I read and study about observability, right? It mentions that the goal of observability is actually to provide a level of introspection or details that helps you understand the internal state of the systems. So the keyword here is internal state. Tell us more about this. How do you differ this with something that monitors external state?
Yeah, so I think that when you're measuring external state, you are measuring things like what's the CPU utilization, what's the memory utilization. Those are things that are potentially useful, but they don't give you an idea of what was the application doing at the time that this particular request executed. So I think that kind of detail into what was the code actually doing and not what are the side effects of the code. I think that's kind of what differentiates observing it from the inside out rather than from the outside in.
The other thing that people in the industry are used to traditionally, we call it monitoring. So when we talk about system administrators last time, we used to talk about monitoring. And in the past, I don't know how many years recently, is we start to shift from monitoring to observability. So is there any significant difference between monitoring observability, or is it just another term being coined to brand the same thing with a new term?
To me, observability is a superset of the capabilities that monitoring would provide. So to me, they are not at all synonymous because with monitoring, you're just trying to figure out when something has broken, but it won't necessarily answer why, which is why people had considered for a long time, I use my monitors to tell you something has gone wrong and I use my logs to figure out what happens. Guess what? In a complex distributed system, logging is not going to save you anymore. It takes forever to search through. It doesn't give you causality of what caused what. So when we think about the relationship of monitoring and observability, I think this is why I mentioned service level objectives earlier. To me, service level objectives are kind of monitoring 2.0. They're the answer to the tell me when something has gone wrong that monitoring played before. Whereas observability kind of maps more closely to me to kind of replacing logging than it does to replacing the metrics we used for monitoring in the past. So what do I mean by this? Well, when you have your service level objectives, you define what a acceptable level of success is. For instance, at Honeycomb, we aim for our ingest pipeline to be 99.99% reliable. That means no more than 1 in 10,000 packets of incoming telemetry are dropped. But if we start seeing an elevated error rate, if we have, say, we're allowed to drop 1 million telemetry packets per month, and we start dropping 100,000 per hour, we're going to exhaust that error budget for the month in 10 hours. To us, that's an emergency. We'll go and fix it right away. But if we have like 1,000 bad requests that are just being dropped per hour, that's going to take 1,000 hours. That's not an emergency. So kind of it differentiates between expected levels of errors and unexpected levels of errors, and is not susceptible to the same problem that people have had with monitoring in the past of, oh my God, it's 2 a.m. 1 out of 1 requests failed. That's 100% error rate. Wake up everyone. No one likes to be paged at 2 a.m. for something that flaps and goes right away. So like peanut butter and jelly, they go better together. And then together they kind of provide a superset of the kind of monitoring and logging that people used to do in the past.